right, so what do we got going tonight?
The more of the final review for Math Excel.
Okay.
I'm just signing in right now.
Okay. When is your final? It's Monday, or?
It is Monday,
I
yes.
thought that's what you had said. And we're meeting at noon at the library on Sunday, right?
Right.
Okay.
Let's solve the equation.
Okay.
S squared plus 3s equals -8.
Okay. What's the first thing I'm going to try?
To get the s squared by itself, or no, to move it all on the left and make it equal to 0.
Exactly. In other words, let's try this. This is typically the way you solve a quadratic. But now, when we look at it, we can see that there are no factors of 8 that add to 3. And that's what we would need to factor it. Okay? So I got two choices at this point. I can put the 8 back on the other side of the equation and complete the square, or I can plug it into the quadratic formula. I'm inclined to think the quadratic formula is probably the right method.
Okay.
What is the quadratic formula? Give me the general equation.
I believe it's x equals square root
No?
of...
You want to make sure you get this memorized, because you're going to have to know it, if not this year, next. For sure.
Okay.
Okay, and I don't know if this helps or not, but notice the first half of it is the same as the vertex of a quadratic.
Right.
Minus b over 2a. So if you remember what the vertex is, it helps you remember the quadratic, or vice versa. If you remember the quadratic, then you know what the x-coordinate of the vertex is. Okay. Plug in for me with minus b.
So minus b is going to be -3s.
Just -3. Does not include the variable. You're only talking about the coefficients. In other words, a is 1, b is 3, and c is 8. Not talking about any of the variables.
All right. So -3 plus minus square root of 3 squared, just the coefficient, minus 4 times s squared.
No, just the coefficient.
So just 1?
Uh-huh. Look up here. This is what a, b, and c are for this quadratic.
Okay.
Times what?
Times 8.
Okay.
Divided by 2 times 1. So just 2.
Okay. What's the first thing you notice about this? Have you had imaginary numbers?
I don't think so.
Why are they giving you this problem? Because this problem produces only imaginary solutions. This problem has no real solutions, and the way I can tell is what's going to be inside the radical. It's going to be 9 minus 32, right?
Right.
Well, that's negative 23. In other words, if I do the math here, I end up with negative 23. Well, when you go to take the square root of a negative number, you get imaginary solutions only. So,
well, there's an answer choice that says the solution is not a real number.
Oh, that's it. Now, let's talk about something as long as this is a question you're getting.
Yeah.
This inside the radical actually has its own name. It's called the discriminant. Okay? And the reason it has its own name is because frequently when you go to solve a quadratic, you'd like to know whether it has real solutions or imaginary solutions. Because if it has imaginary solutions, you're done, right? In other words, if you could have told that this only had imaginary solutions, you would have had the answer right immediately off the get-go. Well, the way you can tell that is by examining the discriminant. The discriminant is 9 minus 32. If that is a negative number, then you're going to have only imaginary solutions. If that is a positive number, you're going to have two real solutions. And if that number is equal to 0, you're going to have one real solution only. Okay? So that would have actually helped us here. Because if we would have examined b squared minus 4ac, we would have immediately seen that it was negative, and you could have answered your problem immediately looking at the choices.
Mm-hmm.
So, in a way, that should help you memorize the quadratic formula. Because basically what the quadratic formula is, it's that first half, which you should know, plus or minus the square root of the discriminant. And that's it. And if you can remember it like that, you won't ever get it wrong. And the discriminant is not the square root of that. The discriminant is b squared minus 4ac.
Oh, so it kind of all fits together.
Fits together very nicely. In other words, if b squared minus 4ac is a positive number, then you're going to have real solutions. If it's negative, you're not. And if it's exactly equal to 0, you're going to have one real solution. So it's almost worth figuring out the discriminant before you begin. I didn't realize that you had already talked about negative numbers in class, so I didn't even think to do that on this. Couldn't imagine it would be a negative discriminant, but it obviously is. And they haven't taught you imaginary numbers yet. There's actually a way to write that answer using imaginary numbers, but you haven't had it yet. You probably won't get that until Algebra 2.
Yeah.
All right, what else?
The next one is solve by the quadratic formula and simplify.
Okay.
It's 6x squared plus x minus 5 equals 0.
Okay. Let's examine the discriminant immediately. Even though they told you to use the quadratic formula, which means that at some point in time we're going to have to answer what this is, right?
Right.
Well, what is that?
That'd be 1 minus 4 times 6 times negative 5.
Forgot the 4. Oh, no, you didn't. Sorry. Here, let's write it the way I'd like to see it written. Because there is so much room to make a mistake here that you don't want to do anything that might make a mistake.
Yeah.
Okay. So, is the discriminant positive or negative?
It's How would you find out if it's positive or negative?
Well, you got the number 1 minus a negative number. And the secret here is always do those 3 first. Okay? Just make it a habit. Because C is frequently negative. And a lot of times when you put that negative sign there, it really confuses people because they're looking at 2 negative signs. Well, this one's subtraction, but that's a negative sign. And the differences are gigantic. Okay? So just to avoid the problem that you might do double subtraction, come up with that number right there without this minus sign. In other words, these 3 numbers, what is that?
Let's see, 24 times 5.
It's easier if you do the 5 times 4, because then you get 20. And what's 20 times 6? I know you know that.
120.
Right. So it's minus 120, right? Because it was 4 times negative 5 times 6. So we are subtracting a negative number, which is the same as adding it. So that's what the discriminant is plus 121.
And now we plug that in?
Well, we don't even need to plug it all in. I mean, we are going to plug it in, but we already know the discriminant, so we've done half the work already. What's minus b?
Minus b is negative 1.
Plus or minus the square root of 121, I'll write it like that for a moment, all over what?
Over 2.
12. 2 times a. A is 6.
Oh, okay.
Okay? Now, let's simplify this thing. What's the square root of 121?
11.
So I'm going to replace that with 11. Now, what are my 2 answers? Quadratics are always going to give you 2 answers. That's why there's the plus and minus there. Unless that discriminant is exactly 0, and then you would only have 1 answer, which is this one right here, minus 1 over 12. But in this case, it's not. It's a positive number. So what's the first answer?
Negative 1 plus or minus 11 over, wait.
What does that plus or minus mean? In other words,
10 over 12.
Okay, so the first answer is 10 over 12.
Right.
Converts to 5 over 6. You never want to give that answer. What's the second answer?
Negative 1.
Yeah, and there's your 2 answers, solved by the quadratic. Now, just for your info, because we came up with non-rational, in other words, because we came up with rational numbers, 5/6 is a rational number, minus 1 is a rational number, what that means is we could have factored that. It has to factor. Now, I understand that they said solve it by the quadratic, and I can tell you what the factors are. They're x plus 1 and 6x minus 5. Notice that produces the proper middle term and gives you the same 2 solutions that we just came up with using the quadratic. But it would have been a little faster had we factored it, right? In other words, if I'd have known that that was the factor, I'd have been done a long time ago. Because now I know that x could be equal to 5/6 or x is equal to minus 1.
Oh, okay.
Okay? So usually you don't use the quadratic if you can factor something. And that's why I always give it a shot to see if I can factor it, because it's so much easier. But if the instructions say solve it by the quadratic, then you solve it by the quadratic regardless of whether it can be factored or not. Although in this one, this is on your computer, right? And the only thing you have to put in is the two answers for x. So how would they know whether you used the quadratic to solve it or factored it to solve it? Would they?
Well, yeah, because the quadratic would produce two answers, right?
So does the other way. In other words, when I factored it, here's what I got. Well, that's two answers. X can be equal to -1 or x can be equal to 5 divided by 6. So I got the exact same two answers that I got using the quadratic formula. This is what I got using the quadratic. And I would expect to get the same. I mean, you're not ever going to get two different answers.
Right.
They're always going to be the same. Quadratic formula is just another way to solve quadratics. It's just a little harder than factoring. In other words, if you can factor something, it's usually going to be a little easier. Notice that if I'd have known that was the factor, I had my answer instantly. I didn't have to do any of this discriminant stuff. I didn't have to plug it into the quadratic formula. I didn't have to do all the heavy lifting if I knew that that was true right away.
Okay.
Okay. And on these computer, on Math Excel, I'm having a hard time figuring out how they're going to make sure you did it by the quadratic formula. Unless they actually ask you what was the discriminant. That'd be a good way to do it. Where it's actually what the discriminant is, and then you have to do it by the quadratic formula. All right. What else do you have?
Rationalize the denominator.
Okay.
Radical 3 over radical 5.
Now, here's what the problem is. That is an irrational number. Every square root that is not a perfect square is an irrational number. Here, let me list them. Notice that the only one I left out were the perfect squares. These are all irrational. If you have a radical, it's an irrational number unless it converts to a perfect square. In other words, square root of 4 is 2. So that is not irrational. It's rational. Okay? So it's important that you understand what irrational means. And in the context of these kind of problems, that's what it means. Anytime you have a denominator that you can't turn into a perfect, you have to rationalize it. Now, there's a rule about fractions. I can multiply a fraction by the number 1 without changing its value. Always. No matter what the fraction is. Okay? Important concept. It's a little bit like the concept with equations that says you can do whatever you want to the left side as long as you do it to the right. Well, it's not quite that liberal with fractions. With fractions, you can't do anything you want to the top as long as you do it to the bottom. I can't square the top and square the bottom and come up with the same fraction. But what I can do is multiply that fraction by the number 1. In this case, my number 1 is going to be that.
So the reciprocal? Or no?
Whatever the denominator is. You want to multiply the denominator by the same radical. In other words, the moment I see square root of 5, I know I got to multiply by the square root of 5. Why? Because that turns it into 5, which is a rational number. What do I have in the top? Square root of 15. Now, even though that has an irrational number in the numerator, that's okay. You can have irrational numbers in the numerator. You just can't have them in the denominator.
Okay.
Okay.
And we did something wrong if we have it in the denominator.
So rationalize this for me.
So we take root 2 over 2, multiply it.
Root 2 over root 2, right?
And then
what's that produce?
That would be that would just be 2 over...
No, it would be root 2. The top is 1 times root 2, so it's still root 2.
Over 2.
Right. And all of the common ones, you're going to get really good at them. In other words, 1 over root 3 is root 3 over 3. 1 over root 5 is root 5 over 5. 1 over root 7 is root 7 over 7. Okay? So you don't, with some of these, you're just going to memorize it whether you try or not, and you're not going to have to go through the rationalization process. Now, the fact that they gave you a numerator that was root 3 and a denominator that's root 5 changes nothing really, other than I don't instantly know what it is. In other words, I do feel a need to go through the math here, make sure I get the numerator correct, which is root 15, and that is simplified. And the denominator always turns into a real number. I should say the denominator always turns into a rational number.
Yeah.
The other two irrational numbers are pi and e. Both of those are irrational. But we don't have a way of, in other words, if I say what's 1 divided by pi, there's no way to rationalize that denominator, so you got to live with that answer. Even though pi is an irrational number, there's no way to write pi as a fraction.
What's e?
E is another irrational number. It's equal to approximately 2.71. It's probably the second most important number in math, pi being the first. E is the way a lot of things in life grow or decay. Bacteria in a petri dish grows based on the number E.
Okay.
Car depreciates every year based on the number E. So E is a very important number. They don't usually teach it to you until you get to Algebra 2. But it is the second most important number in math and also irrational.
Okay, and pi was the first?
Yeah. And both of those you cannot rationalize. There's no way to rationalize this. So that has to be my answer. Even though I have an irrational denominator, that has to be my answer. I can't multiply the bottom by anything to turn it rational. If it's the square root of 2, I can easily multiply by the square root of 2 to make it rational. But if it's pi or e, can't do it. What do you got next?
Simplify square root 20x to the 5th power.
20x, like that?
Yes, to the 5th.
To what? I didn't quite catch the last few words.
20x to the 5th.
Ah, okay. Makes a big difference. Let's do the numbers first and the variable next. Simplify square root of 20.
5 and 4.
So what does it simplify to?
5 outside of root 4.
No, the reason you factored it into 5 and 4 was because 4 is a perfect square number.
Oh, that's right. So 2 root 2.
2 root 5.
2 root 5.
The root 4 turns into 2. And the root 5 stays the same.
And now what about the exponent?
Well, first of all, we're just talking about root 20 at the moment. We'll get to the x to the 5th. Okay?
Okay.
What's the square root of x squared?
X.
Okay, good. What's the square root of x cubed?
1.5x.
No? First of all,
X.
let's break that x cubed into two things. Let's turn it into
X.
an x squared and an x. That's the same as x cubed.
Okay.
Now we know what that is. What is that again?
X.
So the answer would be x square root x. That's the answer to x cubed. Square root of x cubed. What if it was x to the fourth? What's the square root of x to the fourth?
X squared.
Yeah, because it's the square root of x squared times the square root of x squared. That's x times x, so that's x squared. In other words, you take half of that. When you have an exponent on a variable and you're taking the square root of it, it's basically half of that. But that's if it's even. In other words, anytime I have an even exponent, I'm losing the radical sign. X to the fourth is x squared. What's the square root of x to the 10th?
X to the fifth.
Yeah, those are easy as long as that exponent is even. When it's odd, what you have to do is take out enough so that, in other words, I'm going to turn that into x to the fourth times square root of x, which is the same as x to the fifth. And now what does that become?
X squared.
So that's what happens to x to the fifth. Okay? So now we do both. We figure out, well, what was square root of 20? Square root of 20 was 2 square roots of 5. And now I've got x squared times square root of x. That takes care of the whole thing. But now let's simplify it a little bit. I got two radicals. I might as well put both things that are in the radical together. So this turns into 2x squared square root of 5x. Make sure you see how that turns into this.
Okay.
In other words, the same thing that let me take that apart and turn it into square root of 4 times square root of 5 allows me to put it back together. If I've got square root of two different things, I can multiply them together. Well, up here I had the square root of 5. It was multiplying the square root of x. So I just put the 5 and the x inside the radical sign as a simplification. This is what your Math Excel is going to want as an answer. It's exactly like that.
Okay.
If you have more than one variable, just do everything a piece at a time. In other words, let's say we had this. Okay? Well, now that's 2 root 5 times x squared times square root of x times y times square root of y. Now I put all three radicals together, so I end up with 2x squared y times the square root of 5xy.
Okay.
I realize you're probably not going to get something that difficult yet, but it's not that big of a leap over this problem here. In other words, this problem here had a number and a variable. I can add as many variables as you want. I can put in 3 variables. Doesn't change the degree of difficulty. I'm still going to work on the 20 first, the x to the 5th next, the y to the 3rd after that, and the z to the 7th after that.
And they're odd, so we can't just break it apart.
Yeah, when they're odd, it just merely means you're going to have a radical in your answer. You can break it apart. In other words, the square root of y to the 7th is the square root of y to the 6th times the square root of y. That's what it is, right? There's a 1 there, so you would add exponents when you multiply them. So now I can take this y to the 6th, the square root of it, and turn that into y to the 3rd. I still have my square root of y, though. So this becomes that. So I can break some of it out, just not all of it. If it was an even exponent, I'd be able to break all of it out. What else, James?
Let's see. Negative 10 over root a to the 7th power.
Okay.
So we'd take negative a 7th and multiply it.
Well, there's two ways to do this. Let me do it the way that I think is the simplest. Okay? That bottom is going to give you an irrational number. So we have to rationalize it. Well, what do I have to multiply the bottom by in order to rationalize that?
A 6th over times a.
Just a to the 7th, like that. If I multiply these two together, I get a to the 7th, which is a rational number. Well, if I multiply the denominator by that, I got to multiply the numerator by that also. Now, multiply across, what is the new numerator?
Negative 10 a 7ths.
Negative 10, the square root of a to the 7th. That's the way you pronounce that. And it's all over a to the 7th, like that. Now, I can do some simplification. That's not really my final answer because I can simplify that, right? What does that equal to?
A to the 6th power.
A to the 6th times, in other words, the square root of a to the 7th. If you need to do it in two steps, always do this way. Well, now what is the square root of a to the 6th?
A to the 3rd.
Okay. And I still got a square root of a, right? Now, when I put it all over a to the 7th, I can do some major simplification here. What does this become?
A to the 4th on the bottom.
On the bottom, exactly. So I can erase that completely and change it to a to the 4th. And so this is my final answer. That minus 10 is multiplying square root of a. But now it's perfectly set up. I've got an irrational number in the numerator, but not the denominator. And that's what's important.
Okay.
Okay. You could have taken that a to the 3rd out before doing anything. In other words, let me just show you an alternate way to do that problem. I'm not sure that it's necessarily easier or better. But if I decided to split that up right away, I would get minus 10 over a cubed times the square root of a, right? Now, in order to rationalize it, I only have to multiply it by square root of a. Top and bottom always. Now, that gives me my final answer immediately, or almost immediately. Square root of a times square root of a is a. A times a to the 3rd is a to the 4th. So I get the same answer even if I start separating that out as my first step. And some would say that this might even be easier, this way here. Because notice the first time through, I had to multiply it by the square root of a to the 7th. Then I eventually had to take that, whittle that down. So as long as I got to whittle it down at some point, no matter what, might as well do it right off the get-go right here. And then when I rationalize it, it comes out to the final answer, and I don't have that a to the 3rd over a to the 7th like I did when I did it the first way. In other words, I actually get the answer quicker, I think, this way. There were 2 steps to get the answer this way, and there were like 3 or maybe 4 the other way.
Okay.
What else?
Or B outside of square root 7b squared.
Is this what you said?
Yeah.
Okay. So let's go to work on that. There's a number and a letter in there. Let's break all that down. What does that turn into? The part just that I had circled.
The 7 would turn into the 6 and 1.
No? Can't factor 7. That's a prime number. So that's square root of 7.
Right.
So that's what I got. Now the last thing there is that, right? In other words, I've now written it the way you'd want to write it. If you're trying to break this down, separate out the number and separate out the variable, just like I've done. However, there's a lot more we can do to this. What's the square root of b squared?
E.
Okay, so now we have this. Now b times b is b squared. So I'm going to put the numbers next to one another, and I'm going to put the letters last. So that's my answer. And it's not b squared because it started out b squared. The square root of b squared is b. But then you have a b times another b, and it turns into b squared. So.
And it accepted it.
In most of these problems we've been doing lately, there's only one way to really present the answer. Well, that's not really true. There were lots of mistakes we could have made here. Not simplifying, for example, in both of these problems. So it wouldn't accept that if we hadn't have simplified everything. All right, what else?
Solve the radical equation x equals square root 3x plus 10.
Okay, when you have a radical sign in an equation, what you usually want to do is isolate it and then square both sides. Well, it's already isolated. We don't need to isolate it anymore. In other words,
so square the square root to
if
go
there was a plus 1, I'd want to get rid of that plus 1 before I squared both sides. Okay? But there isn't. It's already isolated, so when I square both sides, what do I get?
You get x squared equals 3x plus 10.
Yeah, and now how do I solve it?
You could
when you're thinking quadratic, always be thinking 0 on one side of the equation.
So then you could minus it over and make it equal to 0.
That's almost always what you want to do. And I say almost because if you have a quadratic that doesn't have an x term, there's other ways to solve it. But this always works, doing it this way. This is called standard format, okay? Standard format is ax squared plus bx plus c equals 0. And this a, b, and c are the a, b, and c from the quadratic formula. Okay? So the beauty of having it in standard format is twofold. First of all, it allows you to try to factor it to solve it. And if you can't factor it, it allows you to immediately start plugging it into the quadratic formula. So can we factor this? So
yes.
Into what?
X minus 5 and x plus 3.
Remember, the two numbers have to multiply to the constant.
Right.
So it's got to be x plus 2. In other words, 5 times 2 is equal to 10, not 5 times 3.
Right.
And this works because that gives me minus 5x when I multiply the inside terms, plus 2x when I multiply the outside terms. Add those together and I get my middle term. That means I did the factoring right. Now what's the solution?
B set them equal to 0, so it would be the opposite, so x plus 5 and x minus 2.
Okay. Now, whenever you have radicals in an equation, you frequently will produce an answer that is extraneous. In this case, it's not. In other words, both of these answers work. No, they don't. Minus 2 does not work. If you plug in minus 2, well, here's what I would have. Minus 2 for x, is that equal to 3 times minus 2 plus 10? And the answer is no, it isn't. So this answer is extraneous and we discard it. The only answer that absolutely works is x equals 5. Notice if I plug in 5 for x, I get 5 equals the square root of 15 plus 10. That's the square root of 25. 5 equals 5. So this answer works when I check. And always check when you see radical signs. There's 3 things in equations that tend to produce extraneous solutions. One is radical signs, the other is absolute value signs, and the third is logarithms, which you haven't had yet. But you might have had absolute value, and you definitely have had that. So whenever you see any of those 3 things, make sure you check both answers to make sure they both work.
And it works.
And you put in just the positive answer?
Yep.
Good. Okay.
Next one is find the domain of the function y equals square root x plus 7.
Okay. Whenever you have a radical like this, the one thing we know is that you cannot take the square root of a negative number. You can take the square root of 0, but you cannot take the square root of a negative number. So to figure out what the domain is, I'm going to take whatever's inside the radical and make sure that it is greater than or equal to 0. Because it has to be. If it's negative, I can't take the square root of it. And this controls the domain. So now when I solve this inequality, I get x is greater than or equal to minus 7, and that is the domain. X has to be greater than or equal to minus 7. Now,
Minus 7.
What's that?
Oh, I was just agreeing.
Now how you enter that in Math Excel might be a little interesting because there's various ways to enter domain. This is a simple way, and there's a few that are more complex. Interval notation, has anybody mentioned that to you?
Not yet.
Okay, then that's probably the way they want you to put it in. X is greater than or equal to -7.
And it accepted that.
Yeah, now let's make it a little more complicated. Let's say the problem was this. Well, same logic applies. I'm going to take whatever is inside the radical and force it to be greater than or equal to 0, and then solve that equation or inequality, and that will be your answer.
Okay.
So it doesn't matter how complex it is. I can have a quadratic in the numerator. I could have a cubic. Whatever is under the radical has to be greater than or equal to 0. That's how you're going to come up with your domain.
Okay. Write the ratio for cosine B.
Is there a picture associated with it?
There is.
It's a triangle.
Yes. It's A at the top, angle, B to the right, C on the bottom. Between A and C is 56. Between C and B is 33. And between A and B is 65.
65?
Yeah.
Okay. So the cosine of B. Here's what the most important thing you can remember about trig. SOHCAHTOA. So what is the cosine equal to of B?
It's equal to...
It's the adjacent side.
56.
No, that's the opposite side.
33.
Well, you're not wrong. 65 is an adjacent side. But in trig, we never mean the hypotenuse. When you see an A and it means adjacent, it always means the adjacent side that is not the hypotenuse. So 33 is the adjacent side. Over what?
Over adjacent over hypotenuse, so 65.
Right. And that is simplified. I can divide that by 3, but I know I can't divide that by 3 because the numbers add up to 11. For a number to be divisible by 3, they have to add up to a number that is divisible by 3. Neat little...
And that's...
Okay, cool. All right.
Use a calculator to find the trigonomic value. Tan 61 degrees.
Make sure you do that and get an answer. What do you get?
Get my calculator out. After plug that in.
In other words, we don't need to do these online, but I want to make sure you can do one of them.
1.8.
Sounds right. Try the sine of 30. That'll tell me whether you're in degree mode or radian mode.
the sine of 30.
Should be 0.5.
0.5.
That says you're in degree mode. In other words, if your calculator was accidentally in radian mode, you wouldn't get 0.5 for sine of 30. So that's correct for the tangent of 61. Like I said, there's no need for us to do those. So why don't you skip by all of those, do those on your own, and let me help you with more difficult ones than just typing it into your calculator and getting an answer.
Okay, simplified form of 5x minus 20 divided by x squared minus 2x minus 8.
Factor the top.
That would be 5 outside of x minus 4.
Factor the bottom.
That would be negative 4 and 2.
Now what?
The 4's cancel out, that's 5 over x plus 2.
Yeah. No, I'm kind of curious as to what they're going to say when you put that answer in.
They said it's right.
Really? Okay. Because there is a caveat. These two are not identical. Not really equal to that. Caveat is that when I had it in this form up in the upper right, x could never be 4 and x can never be negative 2, right?
Right.
Just because I cancel out that x minus 4, it still maintains the domain restriction. In other words, x can still never be minus 2 and x can still never be 4. Even though you wouldn't know it from looking at that. That's why I say it's not exactly the same as this. It simplifies to this, but the exact answer would be this with both of these domain restrictions. And if you graph it, it actually produces a hole at 4. In other words, you end up with a graph that looks something like this, and they have a hole on it like that. I don't know if you've ever seen a graph like that. But that's what you get when you have a linear factor that got canceled. In other words, you can cancel those two linear factors, but it doesn't take away from the fact that x can still not ever be 4.
And so when it is that, then it creates a hole?
Yeah. In other words, your calculator won't show that hole, but that's what a hole is called. In other words, when you get into a little bit more advanced algebra, they'll talk about vertical asymptotes, horizontal asymptotes, and holes. And a hole is created by this situation that we just had. We would have a vertical asymptote at minus 2. You know what vertical asymptote is? You know what it means?
Yeah. It's the line that it can't cross.
Right. And in fact, if I take this function, y equals 1 over x minus 2, where's the vertical asymptote?
At 2.
And that's a dotted line. You don't actually see it when you graph. And there's a horizontal asymptote at y equals 0. So I know this function's going to look something like this because it's hyperbolic in nature. And the function itself is said to be asymptotic with both the vertical and the horizontal asymptotes. And if it was like the last problem where x couldn't be 4, well then at 4 I'm going to have a hole right there. If I had an x minus 4 over x minus 4, then that leaves a hole there.
Okay.
And you don't see it if you graph it on your calculator because this thing is infinitely small.
Too small for the calculator?
Well, yeah, because the point 4 on the x-axis is only one of an infinite number of points between 3 and 5, right? There's
Right.
nothing special about whole numbers. It's still just a very, very small point on the x-axis. And I mean really, really small. Like I said, there's an infinity of numbers just between 4 and 5. So 4 doesn't occupy a big spot on the x-axis. But big enough that if it can't be 4, then you end up having to manually draw a hole there. But the calculator won't see it because to the calculator it's seeing an infinitely small measurement. So it doesn't put the hole there. Nonetheless, it still exists.
Even though the calculator can't see it?
Exactly.
Okay.
The calculator won't show it. Whether it knows it's there or not, I don't know, but it can't show it because it would have to draw it so small you wouldn't be able to see it. If it drew it the size of the number 4, that point, which is an infinitely small point, then you're not going to see the hole. But I don't want to get ahead of your class. I know you haven't had holes yet, but you have had vertical asymptotes. That's good to know. Have you had horizontal asymptotes?
Yes.
Okay, good. You might actually get holes this year.
We briefly talked about holes, but he said we're not going to be tested on them.
Okay.
The next one is x over x plus 8.
And the question is?
To multiply. And then x minus 9 over x minus 5.
Like this?
Yeah.
Well, there's nothing that can be canceled. In other words, everything's already a linear factor. And what linear factor means is it's x to the 1 is the highest degree of the exponent. There's no x squareds anywhere. Okay, that's a linear factor, that's a linear factor, so is that, so is that. So the best thing I can do, and I don't see how it's going to help, but let's try it, maybe it will help, multiply the tops together, multiply the bottoms together, but there's no way that's going to do anything. And that's not going to allow me to do anything more.
Right.
The only way that would help is if now I can factor this into something other than these two factors, but you never can, so if this is a math Excel problem, then this is the way they're going to want the answer. Because they always want it in factored form. They don't want you to multiply those things together. Put that in as the answer, and that should be it.
Okay.
It shows them being multiplied, but it doesn't actually multiply them. In other words, factored is better than multiplied out. If I multiply these out, then at some point in the future I'm going to have to factor it. So leave it factored if it was factored to begin with.
Okay. It accepted it, by the way.
Okay. All right, it's 7:30. Good to go?
Okay.
All right.
All right, well, thank you, Mr. Cohen.
James, I will see you Sunday at noon at the library.
Sounds good.
All right, bye-bye.
Bye-bye.